So now we're at the quotient property of logarithms. And those of you out in the world of YouTube who don't know me, I teach at Dresden High School. I think very highly of myself. I'm pretty tired though, so this isn't going to be the best introduction I've received, but hopefully it's better than what you're accustomed to. I teach this a log of, I'm trying to think how I do this on the form quizzes, a logarithm of AB, take away a logarithm of CD, can be condensed, so it is equal to a logarithm containing AB over CD. That's how I teach it, okay? So we're going to break this one apart. We're going to look at the rule that I just wrote from right to left. And basically, if something is in the denominator, you take it away. That's kind of the deal. If an argument is in the denominator, we subtract the log. Now, by the way, this should be broken apart. This guy would be log of A plus log of B. And this would be take away log C, take away log D. And you break them apart, that's how it works. So this guy is going to have a positive log T. I should be using that log button. And I'm going to take away a log of V. And I'm also going to take away a log of U. Super Milbrath. This one is going to have a positive log that contains W. It is going to take away a log that contains 3, and it's also going to take away a log that contains X. So like I said, if an argument's in the denominator, the logarithm is negative. That's just how these work. Jump up, see if there's anything interesting. This is the condensing. This is the other way around. I cannot talk. I'm too tired. We condense subtraction with division. Logarithms are the inverses of exponential functions. So this relates to the idea of an x to the a over an x to the b. It is equivalent to x to the a minus b. There's a relationship to those rules. Logarithms are exponential functions. They still are. And it comes from that exponential rule. All the rules of logarithms are derived from the rules of exponents, which for most students is pretty murdered. I don't know why, just is. We're going to have a logarithm, base 10, so we ain't got to specify. It's going to have a lot of stuff. Log 18 was positive. Down low we would have 10 times 16. Now, I'm pretty sure if I type 10 times 16, this thing's going to count it wrong. That's 160. Now, we have 18 over 160. I'm really tired, but I know they're both even. That'd be 9 over 80. I don't think I can take it any farther than that. Going on this one, we're going to have a log base 5. It is a singular log. Any argument or any logarithm that is positive, I put the argument in the numerator. And anything that is negative, I put in the denominator. Now I know this thing's going to simplify. 14 and 8 are both even, so is 18, but anyways, that's 7 over 4 now. And 4 times 18 is what, 72? Seems legit. So 7 70-seconds. That's my resulting argument. Nothing I can do with that, unless I made a mistake with my math. But I didn't. Here we have another one of these. It's very similar, so jump up to level 3, see if anything gets interesting. log base 6 of e to the 5th, and it says write your answer as a sum or difference of a base 6. They want us to expand this thing. It'd be a log base 6 of e, take away a log base 6 of 5, because that 5 was in the denominator, and if you're in the denominator, the logarithm itself is going to be negative, which I've talked about. This one's going to need some simplification. We're going to have a log base 6, and I'm just going to kind of work it out here. Up top, I would have e to the 8th. Down low, I would have an e to the 6th. Oops. Let me get down in there. Too early. E. No breath. I'm struggling here, man. All right, let's try this again. E to the 6th times e in general. So e to the 6th times e is going to be e to the 7th. And now if you look at what we have written, we have e to the 8th over e to the 7th. Well, e to the 8th over e to the 7th is just e. So that wasn't too hard. Bump up to level 4. This is an expansion, not hard. Level 5, another expansion, not hard. Level 6 is a prove. I'm just going to go ahead and take this thing out to spectacular because it won't take long. Can you prove this is true? Well, we'd have a 7e up top. I guess I should write this one out. As tired as I am, I'm probably too tired to visualize. And as much as I like to visualize, you may not have a clue what's going on. This is going to be the natural log of 7e in the numerator. I have two negative logs. They go in the denominator. E to the 6th to e. Now, if I was glancing at this thing, I'd just do that. So, yes, they are the same. Natural log of 7, I can rewrite e to the 6th to as 2e to the 6th. And done. So, yes, this is a true statement. Let's see if I can get another spectacular. Maybe it'll give me a little energy boost here. Probably won't. Is this dude true? So, same idea. The log of 4z is positive. Keep it in the numerator. The other two logarithms are negative. So I'm going to have y squared 6w down low. Well, y squared 6w is going to be, whoa, what was that? Must have got close to the board there. Log 4z, y squared 6w is 6w cubed. Sorry, it's 6wy squared, which is how that would probably be written. And they simplified the fraction, didn't they? That's 2 over 3. That's a horrible looking 3. So 2z, 3y squared w. That is definitely true. And let's see if I get another spectacular. Oh, I missed something. Well, I ain't perfect, am I? Wonder what I did wrong. I guess I didn't simplify. That or I just can't see. Missed something, didn't I? No. Too tired to mess with it.